All right, everybody, welcome to Unit 5. So in Unit 5, we're actually going to be diving deeper, like our magic school bus, into structures. So from our last unit, we learned about ionic, covalent, and metallic, and about their properties and how they behave. The one category that was always the most or the least decisive was covalent, right? Like sometimes they're malleable, sometimes they're not, sometimes they dissolve, sometimes they don't. So in this unit, we're going to dive deeper into just covalence and looking at their things. So our learning target for today is Lewis structures. So I can draw a Lewis structure, which is a 2D representation of a covalent molecule. Okay. With our Lewis structures, this is kind of the end goal of what they're going to look like, is they're designed to show the placement of all the valence electrons in a covalent molecule. Now, those valence electrons can be shown in two ways. They can be shown as what's called a lone pair, which means it's not bonded to anything but oxygen, or it can be shown as a bonded pair, which is in a line. Now, bonded pairs can be single, like the one I circled, or they can be double, like one here. This is called a double bond, or there's also triple bonds, and we'll see how those are formed here in a second. All right, so for our steps for filling out Lewis structures, now our notes are going to look a little bit different. Like your note packet is going to look a little bit different than how I have you fill it in based on how I like to teach it. So keep that in mind. There are a few little differences with certain things, and there might be certain things we just skip completely. Okay, but let's kind of go through the basic steps, and we'll just do a whole bunch of practice together. So the first one is we need to know how many valence electrons those elements have, because valence electrons are the things that are involved in bonding. So if my molecule is NO2 with a minus charge, I would start by finding N on the periodic table. Let me zoom in here. Whoop. Little fuzzy. Okay, but this is nitrogen. That's really fuzzy. And then our trend for valence electrons, remember, goes 1, 2, skip, 3, 4, 5, 6, 7, 8. Oh, why did I write a 7? 8. Okay, and so since nitrogen is in column with the 5, that means it has 5 valence electrons. Okay, oxygen is also in our molecule here. So I find it on the periodic table, which is right next door, and it has 6. Now this little 2 down here on the oxygen just means in our picture we're going to have 2 oxygens drawn. And then the final piece is some molecules are charged, like this one here. Okay, a negative charge means we're going to have a bonus electron that we get to add in somewhere, and a positive charge means we're going to take away an electron. Okay, add this to your notes here, that whenever you add an electron, you spread out. So like it was a -2, spread out the electrons, don't give them both to 1. Spread out to the outside atoms. Okay, and I'll show you once again an example of this. Okay, if we're subtracting, then we're going to remove from the central. All right, step 2 is then we draw what's known as the skeleton structure to figure out how their valence electrons are going to bond. So remember that the goal of bonding is to achieve a full shell. So if you think about how many they come with, it can give you an idea of how many times they need to bond. So for example, let me start with my nitrogen here. Okay, so in my Lewis structure, I would have nitrogen, which has 5 valence electrons that we just identified. Okay, I'm going to place those dots in a circular pattern. So I'm going to go 1, 2, 3, 4, 5. Okay, so I start at the top and then I go around. Okay, so nitrogen has 3 valence electrons, has 5 valence electrons, which means it's going to want to bond 3 more times. Okay, let's place our oxygens. Now, where you place the oxygens doesn't entirely matter. I'm going to place them in a position next to where there's a single dot, because that's going to allow it to bond. So I'm going to put 1 over here and 1 over there. But you could have easily put one, let me get my laser here, right? If you wanted to put it down here instead, that would have been fine, okay? All right, so I could have put it right there. And then I'm going to put my 6 valence electrons, so 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. Okay, like so. Now don't forget we have our bonus electron, okay, and it always gets added to the outside. So I'm just going to add it. Once again, didn't matter, so I'm just going to add it to this one right here. I put it yellow just so you can see where I added it. But we could have easily, once again, given it to this one. All right, so that's kind of what step 2 looks like. Okay, step 3 is then we bond them, okay? Keep in mind that each bond counts as 2, because in order for a bond to form, it's I share one with you and you share one with me, okay? All right, let's see if I can bring our picture over here. Okay, so we're just going to kind of keep building on our image, right? Okay, so now, get my pencil, okay? Start on outside first, okay? Always start outside first. The inside one will always work out, but the outsides are the ones we want to take care of. So if I'm looking at this oxygen here, it has 1, 2, 3, 4, 5, 6, 7. So in order to have a full 8, it needs to bond once. So it's going to be I share one with you, you share one with me, and those 2 dots turn into a bond. And what this gives it is now this oxygen has 2, 4, 6, 8. And so he is happy and stable. Okay, going to the other side of our molecule, if I'm looking at this one has 1, 2, 3, 4, 5, 6. So in order to get 8, this one's going to need to do a double bond. So I'm going to go 1, 2, like so. Okay. So now if I count it to check, we have 2, 4, 6, 8. Oxygen is good. Now, like I said, the central one should always have at least 8. Okay. So the center needs to be greater than or equal to 8. If it's not, then something's wrong. Okay, but in our case, if you look, it is 2, 4, 6, 8. So it's perfect. Okay, but sometimes the center can be overstuffed, and that happens. Okay, so like we just did, step 4 is we check our octets, making sure they have what they want. Another exception to it is hydrogen doesn't need 8. Hydrogen only needs 2 to have a full shell. Okay, and if needed, we create those double bonds. Okay, we're not going to draw a picture in that next box because ours looks how I want it. Okay, oh, but I am going to bring it over here. So let's bring this picture, copy, paste it. Okay, so then the final part to this is if we started with a charge, right? So keyword here is if. You may not have to do step 5. But if you started with a charge, your final answer should show, ignore my box lines there from copying, should have brackets around it, and then we put the charge outside the brackets. Okay, and there's our picture. Now, sometimes you may find you draw a picture and it looks similar to someone else's, but slightly different, right? If we look at this one, we see the double bonds on the left, this one, the double bonds on the right. Okay, but in the end, it all balances out. They all have their 8, right? 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Same thing, 8. Right, so they all have their octets. And so really, both answers are correct. In terms of the actual chemistry that goes on is the molecule actually rotates between these 2 structures, and they're known as resonance structures. And so both would be valid. Some molecules can have up to 4 to 6 different resonance structures. So just know when you check your homework, if yours looks a little bit different, but you look and see like, okay, the double bond has just been moved. Sometimes I think of them as mirror images. Then you're good. You're not wrong. You don't need to change anything. Okay. All right, let's try some practice. All right, we got CF4. Okay, so step 1, we got to figure out how many valence are they coming with. Okay. One thing I failed to mention on our example is the one that's going to go in the center is going to be the first one listed as long as it's not hydrogen. Okay, so carbon's going to be our center, and then our fluorines will be the outside. Now on your note packet, I know there are like some boxes off to the side that say like electron tally and stuff. I don't care about those. We just want to draw the correct Lewis structure. Okay, so let's see if we can zoom in. Let's see if it's any less pixelated than my one before. Still pretty bad, but you can hopefully see it better on yours. Okay, so carbon's here, right? And so it is in the column of 4 valence electrons. So I'm going to start by drawing a carbon. I'm going to go 1, 2, 3, 4. Okay, I then need to add my fluorines. Okay, and I have 4 of them to add. So fluorine on our periodic table is here. So it has 7. So I'm going to add 4 fluorines, 1, 2, 3, 4, and they each have 7s. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now the cool part about Lewis structures is that as you think about how many they have and how many they need, you kind of will start hopefully getting an image in your head created even before it's made. Because in our case, each of our fluorines have 7, so they need to bond once, and carbon has 4 opportunities to do so. So 1, 2, 3, 4, and we're done. And that's our Lewis structure. Okay. One biggest thing remembering is that a line is only created through the connection of 2 dots. Okay, you can't just add a line because you want to. Okay, it has to come from one electron being bonded with another electron. Okay, this one doesn't need brackets because it doesn't have a charge. Let's check our octets just to make sure, right? But we saw 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, and then our carbon has 2, 4, 6, 8. So everybody is happy. Okay. All right, let's try another one. NH3. All right, so nitrogen is right here on our table, and he has 5. Okay, so 1, 2, 3, 4, 5. Okay, we got 3 H's to place around it. Once again, I'm going to choose to place them by where there's a singular electron because that allows bonding to happen easier, like so. Hydrogen only comes with 1. And if I focus on hydrogen, it only needs to bond once. So I'm going to do dot to dot, dot to dot, dot to dot, and we're good, right? Hydrogen has its 2, and nitrogen has its 8. All right, let's try another one. Okay. All right, we got SO2 2 minus. Let's try another one. So we got SO2 2 minus. So sulfur comes with 6. So 1, 2, 3, 4, 5, 6. Okay. Now oxygen also comes with 6. So I'm kind of thinking ahead here. Once again, it's okay if you don't and you have to kind of move things around in the end or draw some wonky lines, right? As long as you have the right number of bonds and things, it's all good. But what I'm thinking is I know this has 6 valence electrons, which means that tells me it's going to bond 2 times. Okay? But I also noticed that I have a charge of -2. So they're actually each going to get a bonus, which means I really only have, which means they would each have 7. So since they're only going to need to bond 1 time, I'm going to place them on the side with the single dot. Okay? Now once again, if you chose to put it here and here, that'd be fine. Okay? As long as you have the right number of double, single, triple bonds and things, it doesn't matter. Okay? All right, so oxygen comes with 6. So 1, 2, 3, 4, 5, 6. Okay? 1, 2, 3, 4, 5, 6. And then I'm going to add my 2 bonuses. So I'm going to add 1 here. Oops, that did not stay. 1 here and 1 here. Because remember, we spread out the negatives. We don't give them all to 1. Okay, so now, like I was recognizing, since this has 7, it's only going to need to bond once. Opposite side, same thing, only need to bond once. Okay, this one does have a charge, so for my final answer, I need to show brackets and 2 minus. So this would be an example of where we'd say that the sulfur has 2 bonded pairs and 2 lone pairs. A lot of times when we're counting bonding and lone, we're focused on just the one in the center. All right, let's keep going. Okay, I'm going to skip this one because I want to see this one here. Okay, so let's do N2. Okay, so we got nitrogen. Comes with 5. 1, 2, 3, 4, 5. And another nitrogen. So 1, 2, 3. Oop, I did that weird. 3, 4, 5. Okay. All right, so if I'm focused on the nitrogen, it needs to bond 3 more times because it has 5, right? Remember, and the goal is to get to 8. And so we're going to need 3 bonds to make that happen. So in this case, we're going to go, okay, 1 bond, 2 bond, and 3 bonds. Okay. Oh, hold up, friends. Did you see what I did wrong? I gave our original nitrogen over here 1, 2, 3, 4, 5, 6. It only had 5. Okay. So I'm going to get rid of that dot. Great example from a mistake of sometimes if you just start off wrong, it's going to mess you up. And so you'll just have to backtrack a little. Okay, I'm going to redraw this just to clean up my lines. So it's going to be N with a triple bond in the middle, and then they both have a lone pair. And so that would be my final answer. Okay, once again, if we count for this nitrogen, it has 1, 2, 3, 4, 5, 6, 7, 8. And then the same thing on the other side. So once again, we only did a triple bond because we needed it. If we go back to this other example, oxygen didn't need more than 1 bond, so we didn't give it more than 1 bond. A common mistake I see students make is adding double or triple bonds when they're just not needed. So pay attention to how many they have and how many they need to get to 8. All right, let's try this fun one. All right, so we got sulfur again, 6. Do this for me. If you're feeling good about it, go ahead and hit pause, and you can try this one on your own. And if your answer matches mine, then you can have a smiley face when you're done. If you're still feeling a little uncertain, then you can go ahead and keep following along with me, and then we'll have you try the next one on your own. Okay. All right. So sulfur's coming with 6. 1, 2, 3, 4, 5, 6. Okay. And then oxygen each comes with 6. So 1, 2, 3 of them. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So once again, I'm focused on the outside atoms. Okay. The oxygens have 6. Oops. Not equals. They need something to get them to 8. And so each of them are going to need to bond twice. Okay. So we're going to go 1, 2, 1, 2, and 1, 2. Okay, so if we look here, this oxygen has 2, 4, 6, 8, and they all do now. Now let's take a look at our sulfur in the middle. Okay, so sulfur here has 2, 4, 6, 8, 10, 12, and it's actually okay. This is why I said that the central atom has to be greater than, has to be greater than or equal to 8. Okay, so it can't be under 8, but it could be more than 8, and that's totally fine. This is the right structure for our SO3 molecule. All right, let's have you try this one for a smiley face, and then once you're done, hit play and see if your answer matches mine. All right, so my carbon has 4. Oxygens come with 6. Okay, so focusing on my oxygens, they're going to need to bond twice on each side because they have 6, just like before. Oop. Okay, now once again, if my picture looks a little crooked, I would probably redraw it just to make it easier to read. So kind of like this is my scratch work, and this is my final answer. Okay, and then pair up dots. All right, so notice same number, 1, 2, 3, 4, 1, 2, 3, 4. It just looks a little cleaner to pair them up, easier to follow. And this is our picture. So if you have that on your paper, go ahead and give yourself a smiley face. Okay? All right, that's it. Go ahead and you're going to pull out the homework packet and give that one a go. I've posted a few of the answers on Canvas so you can check yourself, have confidence in what you're doing, compare with one another, ask each other questions, and then when you're done and you've checked the ones that I've posted at least, you'll take a picture and submit it on Canvas. Okay? All right, good luck.